Hello student, this is Alakh Bhaiya and I'm here with quiz 7 math solutions. So let's start. The first question on your screen is, if the roots of the equation 2x square minus of a cube plus 1x plus a square minus 2a equal to 0 are of opposite sign, then the set of possible values of a. Now when we have roots of opposite sign, then that means the product of roots is going to be negative. So what we have to do, see, if the roots are of opposite sign, then automatically, so the roots must exist here. So what we have to do, the only thing that you have to do in this question is you have to make product of roots negative. Now product of roots less than 0. So product of root is nothing but constant term upon coefficient of x square. So therefore we have a square minus 2a upon 2 less than 0. So we have a very simple inequality. We have to just take a common from the numerator. We left with a into a minus 2 less than 0. Now this 2 will go in the right hand side and get multiplied with 0. So 0 into 2 is 0. Now you can easily answer. If you want to plot this on the number line and find out by using Webby curve, that's also fine. But I'm writing down the direct solution. So the solution for this inequality is a belongs to 0, 2. We don't have equality here. So with 0 and 2, we have to use small brackets. So the correct answer for the first question is A. Move to the next. If the roots of ax square plus bx plus c are the reciprocal of the lx square plus mx plus n equal to 0, then find the ratio of a is to b is to c. So in this question, lx square plus mx plus n is equal to 0, right? So the roots of ax square plus bx plus c are the reciprocal. So what I'm going to do in such question, what we have to do, just replace x with 1 by x. So we have l upon x square plus m upon x plus n is equal to 0, right? So finally we have n, when you take the LCM, so nx square plus mx plus l is equal to 0, right? So compare with this ax square plus bx plus c, the ratio of a is to b is to c is going to be what? N is to m is to l. So answer for question number 2 is option A. This is a shorter way to answer it. In such question, when the roots of the first quadratic is reciprocal, I mean, you can apply this concept for cubic also for any polynomial, not only for quadratic. This is the first thing. The second thing is, this is a shorter way to answer this. If you want to start with alpha, so if you want to answer in a better way, so what I would say, take the root of lx square plus mx plus n as alpha and beta, and the roots of ax square plus bx plus c as alpha dash and beta dash. So alpha dash is equal to 1 upon alpha, right? So from I mean, if you take the roots as alpha and beta for the second quadratic, and for the first quadratic you can take roots as ax square plus bx plus c. The first quadratic you will take roots as alpha dash and beta dash. According to the question, alpha dash is equal to 1 by alpha. So alpha is equal to 1 upon alpha dash. Now alpha is the root of this quadratic. So what I'm going to do, I'm going to write, so alpha is the root, so we can replace x with 1 upon alpha dash and you will get this. So the ratio of a is to b is to c is n is to m is to l. Move to the next question. In the next question, we have, if alpha and beta are the roots of the equation x square minus x plus b is equal to 0, the value of a is given, that is 69, and we have an expression an is equal to alpha raised to power n plus beta raised to power n. So to answer this question, you must know Newton's identity. So first let me explain what is Newton's identity. If we have a quadratic ax square plus bx plus c is equal to 0, having roots alpha and beta, and we have an expression an is equal to alpha raised to power n plus beta raised to power n. Here minus sign can also be used. So according to Newton's identity, I can write a times of an plus b times of an minus 1 plus c times of an minus 2 is equal to 0. The proof is very easy. It's not necessary to start with n. You can start with n plus 1 also. You can start. So automatically we have to decrease the lower subscript with 1. So if you start with n is equal to n plus 1, so this will be n and this will be n minus 1. Okay. Now we have to use this concept to answer this question. So in this question we have, when I apply the Newton's identity, we have the coefficient of x square is 1, the coefficient of x is minus a, and the coefficient or the constant term is b. So according to Newton's identity, so what I can write here, I can write 1 times of, now as you can see the expression, in the expression we have n plus 1 and n minus 1. So I will not start with an, I will start with n plus 1. So 1 times of n plus 1, I just said in the beginning only, it's not necessary to start with an. You can start with n plus 1 also, you can start with n plus 2 also, even you can start with n minus 1. So the consecutive subscript will be reduced in the same way. So I will start with n plus 1, the coefficient of x is minus a, so I will write here minus a, an, and then the constant term is b, so I will write here b, an minus 1 is equal to 0. So I hope till here all good. Now what I'm going to do, the value of a is given as 69, just substitute there. So we have a n plus 1 minus of 69 an plus of b an minus 1 is equal to 0. Bring this part in the right. Okay, so when you bring the middle second term in the right hand side, because as you can see the expression in the numerator we have an plus 1 plus b times of an minus 1. So I want my numerator to be that only, an plus 1 plus b times of an minus 1. So for that I am bringing the second term in the right hand side. So when you bring the second term in the right hand side, we have an plus 1 plus b times of what was that, an minus 1 is equal to 69 times of an. Now I can split that 69 as 23 into 3. So I am doing all these steps by looking at my expression. Okay, 23 is there. So I can split this 23 an, okay, 3. So 23 an you can bring in the denominator of the left hand side. So we have an plus 1 plus b times of an minus 1 upon 23 an is equal to 3. So the value of this expression comes out to be 3. So answer for the third question is 3, that is option D. Move to the next question. The number of real values of parameter k for which log x with the base 16 whole square minus log x with base 16 plus log k with base 16 is equal to 0. So if you want, you can directly use Sridharacharya formula if you want to. So we have log of x with base 16. I'm using Sridharacharya formula. So this is a quadratic in log of x with base 16. So I'm directly using Sridharacharya formula. So we have log of x with base 16. We have 1 plus minus. Now discriminant is going to be coefficient of second term is minus 1. So 1 minus 4 b square minus 4 ac, so 4 times of log k upon k with base 16. In the denominator we have 2. So from here the value of x is equal to 16 raised to the power of 1 plus minus root over 1 minus 4 log k with base 16 upon 2. Right, so 2 is 2 is in the whole in the denominator. Now, in the question, we have to find out exactly one solution. If I want exactly one solution, here we have plus minus. So, other than if this square root is going to be positive or 0. So, if this square root is going to be positive, in that case, we have two solutions. So, for one solution, this part has to be 0. You can just check out here. We have plus minus. If this square root is positive, then we have two solutions from here. 16 plus minus k something positive upon 2. But in the question, we have to only find out one solution. So in that case, this expression has to be 0. So for one solution, the discriminant must be 0. So therefore, 1 minus 4 log k with base 16 is equal to 0. So when you solve, you will get, I think, 1 is equal to 4 log k with base 16. So log k with base 16 is equal to 1 by 4. So k is equal to 16 raised to the power 1 by 4. So 16 raised to the power 1 by 4. 16 is 2 raised to the power 4. So 2 raised to the power 4 to the whole power 1 by 4 gives you k is equal to 2. So for this question, we have only one value of k. And the answer for this question is we have to find out the number of real values for the parameter k. So answer is A. Move to the next question. Suppose ABC belongs to R and B is not equal to C if alpha and beta are the roots of this. So let's write down the given information. So the quadratic we have is ax square plus bx plus c. Sorry, x square plus ax plus b is equal to 0, having roots alpha and beta. So from here I can write sum of roots is going to be minus a, and product of root is going to be plus b. So this is from the first equation. One more thing I can write as alpha is the root of this quadratic. So I can say alpha must satisfy this. So alpha square plus a alpha plus b is equal to 0. Beta is also the root, so beta must satisfy this. I mean, you guys get to know why I'm writing like this. Beta square plus a beta plus b is equal to 0, right? Now we have the second expression, gamma and delta are the roots of this. X square plus ax plus c is equal to 0, having roots gamma and delta. So from here we have gamma plus delta is equal to minus a, and gamma into delta is equal to c. So this much information we have. Now we have to find out the value of a minus gamma into alpha minus gamma into alpha minus delta upon beta minus gamma into beta minus delta. So we need to simplify this. So when you simplify the expression, we have alpha square minus of alpha times of gamma plus delta plus gamma delta. In the denominator, let's see what we have. When you simplify the numerator, denominator, we have beta square minus of beta times of gamma plus delta plus of gamma delta. Now at the place of gamma plus delta, substitute minus a, and the place of gamma delta, substitute c. So we have alpha square. So when you substitute gamma delta with minus a, that will become alpha square plus a alpha plus c. Because gamma delta is equal to c, gamma into delta. Similarly, the denominator will be beta square plus a beta plus c. Now what after this? As you can see, alpha square plus a alpha plus b is equal to 0. So at the place of, now the value of alpha square plus a alpha is equal to minus b. So I will substitute minus b here. I mean at this portion. In this portion, I will substitute minus b. And beta square plus a beta plus b is also equal to 0. So here also I will substitute minus b. So after substituting minus b, we have c minus b upon c minus b, and that gives you 1. So for question number 5th, the answer is 1. Move to the next question. Right. So in question number 6, if x is real, this is the important line here. If x is real and the value of b is less than c, so actually we have to find out the range of this expression, x square minus bc upon 2x minus b minus c. So in case of rational expression, in case of rational functions, to find out the range, we start by taking the expression as y. So I will start y is equal to x square minus bc upon 2x minus of b minus c. Now simply cross multiply and bring all the terms in one side. So when you cross multiply, we have x square minus bc. When you bring all, after multiplying, bring all the terms in one side. So we have x square minus bc. So x square minus bc is equal to, first let me write all the terms, 2xy is equal to 2xy minus of b plus c into y. So this is what we will get after cross multiplication. Now bring all in at one side. So when you bring all at one side, we have x square minus of, I'm trying to make this make this equation as a quadratic in x. So we have x square minus 2xy. Then we have b plus c into y minus bc is equal to 0. So this is a quadratic in x. This is a quadratic in x. This is a quadratic in x. Now since x is real, it is given x is real. So since x is real, then for this quadratic, discriminant has to be greater than equal to 0. So therefore discriminant has to be greater than equal to 0. Now we have to make discriminant greater than equal to 0. So the coefficient of x is minus 2y, and the constant term we have to treat all this, the last two terms as a constant. So let's do that. So we have 4y square b square minus 4ac minus 4 times of b plus cy minus bc. b plus cy minus bc greater than is equal to 0. Now you can take out 4 common and bring in the right. So we have 0 by 4, that will be 0. So finally we're left with y square minus of b plus c y plus bc greater than equal to 0. Now when you look at, when you observe this quadratic expression, when you observe the left hand side, this is actually a quadratic expression in y. So you can factorize this. So this will be factorized as y minus b into y minus c greater than equal to 0. Now draw a number line, plot b and c. So before plotting b and c, we must know which one is greater. So for that, extra information is given. In the question, it is given the value of b is less than c. So b will come in the left of c. So b will be this, c will be this. As equality is there, we have to take this extreme values. So plus minus plus, we take the positive region. So answer for this question is minus infinity to close b, union close c to infinity. So as you can see, option C is right for question number 6. Move to question number 7. If b is greater than a and c is greater than 0, then the equation x minus a into x minus b and x minus c is equal to. So to answer such question, first write down the quadratic we have, x minus a, x minus b, and x minus a into x minus b minus c. Now what I'm going to do is, this is x-axis and this is y-axis. As b is greater than a, you can take b, no information regarding the sign of a, b. So I'm taking both as positive. If you want to take one positive, one negative, that's also fine. So let's take, here we have a and here we have b, and c is also positive. Now what I'm going to do, as you can see, this is a quadratic expression. This is a quadratic expression in x. Coefficient, when you multiply coefficient of x square, coefficient of x square is positive. When you multiply, you will get x square minus a plus b into x plus ab minus c. So coefficient of x square is greater than equal to 0. That means the parabola is opening upwards. Now what I'm going to do, I'm going to substitute x equal to a. So when I substitute x equal to a, this is the first information we have. I'm trying to draw the graph of this expression. So when I'm able to draw the graph of the expression, we can easily answer this question. So first, when you look at this expression, the coefficient of x square is greater than 0. Now when you put x equal to a here, when I put x equal to a, this expression, so a minus a will be 0, 0 into anything is 0. So we're left with minus c. As c is positive, so this whole expression is going to be negative. Okay. Similarly, put x is equal to b. When you put x is equal to b in this expression, again this get multiplied and 0. Again we're left with minus c, and this is again negative. Why this is negative? Because in the question it is given c is positive. In the question it is given that c is greater than 0. So coefficient of x square is also positive. Coefficient of x square is also positive. Using this 3 information, the only possible graph. So at x equal to a, the y coordinate has to be negative. At x equal to b also, the y coordinate has to be negative. So the only possible graph we can draw is like this. So I can see from here you can easily check 1 root in minus infinity to a and the other root in b to infinity. So answer for question number 7 is, here we have the one root and here we have the second root. So for question number 7, one root in minus infinity to a and the other root in b to infinity. So this is the solution for question number 7. This is a modulus inequality. So let's begin. So as you all know, to solve modulus inequality problem, we have to first find out the zeros of the expression written inside the modulus, and then we have to take cases. So first we need to plot the zeros. The zeros are -2 and 1. The zeros are -2 and 1, right? So we have to make 3 cases. To answer this question, we have to make 3 cases here. So let's begin. So the first case that I am taking, case 1. So the first take that I am taking here, the first case is I am taking x is greater than equal to 1. So if I take x is greater than equal to 1, now this expression will be positive. So x plus 2 will become positive. So if we have positive expression inside the modulus, modulus has no rule that time. So we're left with x plus 2. And when I take x is greater than equal to 1, this expression also is positive. So again, modulus has no rule. So we have minus of x minus 1 less than x minus 3 by 2. So from here, x will get cancelled out. We're left with 3, something like this. When you simplify it further, you will get x is greater than, when you bring that 3 by 2 in the right, we have 9 by 2. X is greater than 9 by 2, right? But this is not my answer. So we have x is greater than 9 by 2 and we have assumed x is greater than equal to 1. So in the case first, this is my assumption, and by assuming this, I got this. So we have to take intersection of this 2. So when you take intersection of this 2, I will get x belongs to, equality is there, equality is not there, x belongs to 9 by 2 to infinity, right? The intersection of x greater than equal to 1 and x greater than 9 by 2 is 9 by 2 from infinity. So this is the answer from case 1. This is the answer from case 1. I can mark the right option from here only, because when you look at all the last 3 options, last 3 option is not including this information, this solution set. So from here only, I can mark the correct option as A, but I'm solving the complete. So we have solved the first case. Now case 2, when x is greater than equal to -2 but less than 1. So when I take x is greater than, this is the second case, x is greater than equal to -2 and less than 1. So this expression is going to be positive. So write it x plus 2. So modulus has no rule, but this expression is going to be negative. So we have to write plus x minus 1 greater than x minus 3 by 2. I hope it's clear to all. So this x we can cancel out. So we're left with here 2 minus 1 is 1. So when you bring that 1 in the right, minus 1 minus 5 by 2. So minus 5 by 2 is approximately, not approximately, the decimal is 2.5. And I have assumed x is greater than equal to -2 and less than equal to 1. So we don't have any common solution here. My assumption is this. This is my assumption. By assuming this, I am getting this. So these 2 sets have no common points. So from the second case, answer is 5. In the same way, if you take the case third, in the case third, that is x is less than -2, you will get 5 again. I know because I have solved this. Let me check also. So this will also, let's check let's check whether we are getting 5 or what. So when you take x is less than -2, this expression will be negative, this expression will be also negative. So minus x minus 2 plus x minus 1, right? Then we have less than x minus 3 by 2. So this x and minus x will be cancelled out, and we have so minus 3 plus 3 by 2 LCM will be, so from here I will get x is greater than 3 by 2, x is greater than when you do the correction, it comes out to be x is greater than minus 3 by 2, right? So what I have assumed x is less than minus 2 and we are getting x is greater than minus 3 by 2. So there is no common point as such. When you take common, when you take intersection, you will get 5. So from third case also we are getting 5. So when you take the union of all the three cases, the only solution we have is 9 by 2 to infinity. So for question number 8, the only solution is 9 by 2 to infinity. Now question number 9 is a question of identity, quadratic identity. So if A, B, C are all distinct, then A times of this expression plus B times of this minus x is equal to. Now for this question, first look at the expression. When you multiply all, we are getting a quadratic in x, because the denominators are constants. And numerators, when you multiply the numerators, we have xx, so that will get multiplied to give you x square. So when you multiply all, you are going to get a quadratic, an expression in which the power of x is 2. Now I'm not going to multiply it. If you multiply, that will take more time. It is a Vestas. So I'm substitute x is equal to a. When I substitute x is equal to a, see what will happen. So when I substitute x is equal to a, so the first term, from the first term, a minus b, a minus c, so this will be cancelled out, we're left with a. From the second term, when you put x is equal to a, the second term becomes 0, because a minus a is 0, so the second term becomes 0. Similarly, when you put x equal to a, the third term becomes 0, and we have minus x, so a minus a, that is 0. First thing, I'm repeating again. So this is a quadratic in x, By putting x equal to a, we are getting 0, so a is a root. So from here, I can say x equal to a is one of the roots, right? Similarly, when you substitute x equal to b, we have something b minus b is equal to 0. You can just substitute and check it. So from here also I can say the same thing, x equal to b is one of the roots, right? In the same way, if you substitute x equal to c, what will happen? When you substitute x equal to c, you have c minus c is equal to 0. That means x equal to c is one of the root, is also one of the root of this quadratic. But a quadratic has a quadratic has two roots only. How is it possible a quadratic has 3 roots? This is only possible in the case when this quadratic is an identity. So if this is an identity, this will be reduced to something as 0x square plus 0x plus 0 is equal to 0. So this, when you multiply all this expression, you will get 0x square plus 0x plus 0. So this whole expression is actually written as 0x square plus 0x plus 0, and that is equal to 0 into x square is 0, 0 into x is 0, and plus 0 is 0. So answer for this question is A, 0. Move to the next question. If the equation x square plus 2 times of modulus of x plus 4 is equal to 0 has integral roots, then the minimum value of a is. Now for integral roots, the discriminant must be positive. This is the first thing, the discriminant must be positive. So when I find out the roots comes out to be minus 2 times of mod of a plus minus root over the discriminant is going to be 4a square minus of 16, and in the denominator we have 2. So if I want integral roots, the numerator must contain a factor of 2. The numerator must be divisible by 2, as well as this must be a perfect square. So let's go for perfect square. So if this expression 4a square minus 16 has to be a perfect square. So 4a square minus 16 is going to be, that will be written in the form of k square. So 4a square is equal to k square plus 16. So that implies a square is equal to k square plus 16 by 4. Now a is equal to plus minus root over k square plus 16 by 4. Now you may say, so if I take k is equal to 0, then I will get a is equal to plus minus 2. But for other values also we have, yeah, that's right. If I take a is equal to k is equal to 0, I will get a equal to plus minus 2 and will get integral roots. But maybe that will be not minimum. So from here we'll get plus minus 2. So actually when you put k is equal to 9, k equal to 3. So we'll get a is equal to plus minus 5 by 2. So minimum value is going to be minus 5 by 2. Okay. So for k is equal to 0, we are getting plus minus 2, and the value of a as plus minus 2 and the roots as integral. But for we have a lesser value of a, that is minus 5 by 2. So that will be the answer. And we are getting that minus 5 by 2 for k equal to 3. Let's move to the next question. So this is a nice question of common roots. Suppose a and b are real numbers with a into b is not equal to 0. If the three quadratic equation x square plus ax plus 12 is equal to 0, x square plus bx plus 15 equal to 0, and x square plus a plus bx plus 36 equal to 0 have a common positive root, then mod a plus mod b is equal to 2. So to answer this question, I will take let alpha in the common root. Let alpha in the common root. So if alpha is the common root, what I will do, I will take, so alpha must satisfy the three equations. So alpha square plus a alpha plus 12 is equal to 0. Let's say this is the first equation. And also we have beta square, second equation is, so the second equation is x square plus bx plus 15. So since alpha is the common root, so alpha must satisfy the second also. So we have alpha square plus b alpha plus 15 is equal to 0. Let's say this is the second equation. Alpha is the root of x square plus a plus bx plus 36 also. So alpha must satisfy the third. So we have alpha square into a plus b into alpha plus 36 is equal to 0. This is the third equation we have. Now what I am going to do, and they have common positive root. The root is positive. This is also given. So what I'm going to do, we have three equations. And in these three equations, we have three variables also, alpha, a and b. So we have we have a same number of, we have three equations and three variables. So this question is solvable. Now I'm going to subtract equation 1 from equation 3. So when I subtract equation 1 from equation 3, so alpha square will get cancelled out, a alpha and a alpha will get cancelled out, and we have b alpha, and 36 minus 12 is 24. So b alpha, so actually b alpha plus 24 equal to 0 will be there. So when I bring this minus 24 in the right, we have b alpha equal to minus 24. Similarly, when I subtract equation 2 from equation 3, let's see what I will get. So when I subtract equation 3 from equation 2 from equation 3, so equation 3 is this, and when I subtract, we have b alpha. So alpha square will get cancelled out, b alpha and b alpha will get cancelled out, and we have 36 minus 15, that is how much? 21. So we're left with a alpha. A alpha, we left with 36 minus 15, that is a alpha is equal to minus 21. Right, so I'm trying to find out the value of alpha. For that, what I'm going to do is I'm going to add equation 1 and equation 2. So I'm going to add equation 1 and equation 2 and subtract this sum and subtract equation third from this sum. So when I add equation 1 and equation 2, what I will get? I will get 2 alpha square plus a alpha plus b alpha, that is a plus b alpha, 12 plus 15, that is 27. And equation third is alpha square plus a plus b alpha plus 36. So when I subtract 1 plus 2 minus 3, so first I am saying to add the equation 1 and equation 2 and subtract equation third from this sum. So you will get alpha square. Now in this case, a alpha cancel out and b alpha also cancel out. And we have 27 minus how much? 36. So 27 minus 36 is how much? Minus 9 is equal to 0. So alpha square minus 9 is equal to 0, right? Alpha square minus 9 is equal to 0. So the values of alpha is equal to 3 or minus 3. I can't take minus 3 because in the question it is given the root is the common root is positive, so I'm taking alpha equal to 3. So when you take alpha equal to 3, the value of b is minus 8. When you take alpha equal to 3, the value of a is minus 7. So B's, we are getting -8, and when you put 3 here, we are getting A as -7. So when you take the mod of A and B, you are getting 8 plus 7, that is 15. So answer for question number 11 is 15C. Now we have the next question. We have, please focus on question number 12. Px is equal to x raised to power 5 plus x square plus 1. So I can write it as x to the power 5 plus x raised to the power 4, 0 into x raised to the power 4 plus 0 into x cube plus x square plus 0 into x plus 1, right? It has given this px as root x1, x2, x3, x4, x5. So I can say, by looking at this, I can say sigma x1, the meaning of sigma x1 is sum of all the roots taken at a time. So that is going to be 0. Now sum of root taken 2 at a time, that is sigma x2, it is also going to be 0. That is coefficient of x cube upon coefficient of x raised to the power 5, that is 0. Now sum of root taken 3 at a time, so that is going to be coefficient of x square minus of coefficient of x square upon coefficient of x5, so that is -1. Again we have sum of root taken 4 at a time, so it is going to be 0. That is sum of root taken 4 at a time is it is going to be, so it start with minus, plus, minus, plus, that is coefficient of x upon coefficient of x to the power 5, that is again 0 because coefficient of x is 0. And the last one is sum of root taken all at a time, okay, or we simply say sum of root taken all at a time. So sum of root taken all at a time is nothing but product of roots, because when you write sum of root taken all at a time, we have only 5 roots, so we're left with only one term. So simply you can say product of root also. You can also write product of root, because we have only one term in sum of root taken 5 at a time, and the value is going to be how much? So minus, plus, minus, plus, minus, it is going to be -1. I hope it's clear. Now we have another, we have qx is equal to x square minus 2, and we have to find out product of qxi, I goes from 1 to 5. So actually what we have to find out, let me check again, x square minus 2. So we have to find out x1 square minus 2, x2 square minus 2, x3 square minus 2, x4 square minus 2, x5 square minus 2. So when you multiply this, that will be complex. So what I'm going to do, I'm going to write in this way first. I can write 2 minus x1 square, 2 minus x2 square, 2 minus x3 square, 2 minus x4 square, and 2 minus x5 square. We can use the identity a square minus b square. So I'm going to split this. I'm taking the plus 1 together. So root 2 minus x1, root 2 minus x2, root 2 minus x3, root 2 minus x4, and root 2 minus x5, right? In the same way, you can also write root 2 plus x1, root 2 plus x2, root 2 plus x3, and the last one is root 2 plus x5, right? If you want to replace root 2 with any other k, so that will be more understandable, but I'm keeping as it is. So you can think this, I'm using another pen to make you understand. So when you look at this expression, when you multiply all, so you can imagine this as, this is a polynomial, a polynomial of degree 5, written as product of its factor. A polynomial of degree 5 is written as product of its factor. So, and similarly, a polynomial of degree 5 here also written as product of its factor, okay. So when you multiply all this, I'm just telling, okay, so we are not supposed to multiply, okay. So what I'm going to do is, so when you multiply, you know what you will get, minus is already outside, you will get root 2 raised to the power 5 minus of sum of roots. So we can write sigma x1 root 2 raised to power 4, and then plus sigma x1 x2 root 2 raised to power 3 and so on. In the same way, when you multiply this one, you will get root 2 into root 2 raised to power 5 plus of sigma x1 root 2 raised to power 4. Then we have minus of sigma x1 x2 root 2 raised to power 3 and so on. Now substitute the values of sigma x1, sigma x2, x1 x2, sigma x1, x2, x3. You will get the answer, okay? So you can simplify from here. Just substitute the value of sigma x1 and here you can substitute sigma x1, x2. I'm repeating again what I have done here. As you can see, root 2 minus x1, root 2 minus x2. So you can, if you want to substitute root 2 as y, so you can think this is the first 5 term is actually when you multiply the first 5 term, you will get a polynomial of degree 5 in y, right? So when you multiply, you will get a polynomial of degree 5 in y. And that polynomial can also be written in this form, root 2 raised to power 5 minus sigma x1, because the coefficient of y is, when you multiply all, I have replaced root 2 with y. So the coefficient of y raised to power 5 will be 1. So this whole expression, this whole product can be written like this, root 2 raised to power 5, I mean y raised to power 5. We will later replace y with root 2. Root 2 raised to power 5 minus sigma x1 root 2 raised to power 4 plus sigma x1 x2 root 2 raised to power 3 and so on. And after that, nothing we have to do. We have to just substitute this value, sigma x1 0, sigma x1 x2 equal to 0, sigma x1 x2 x3 equal to minus 1 and this equal to 0. So when you do all, the answer is going to be minus 23. Just replace the values of sigma x1 and you will get the right answer for this. Move to the last question. So this is a question of logarithmic inequality. So first we have to understand few things. If we have log of x with base a, if I want log to be positive, so we have to, a log is positive, a log is always positive when the argument and the base lies at the same side of unity. Okay, so when argument and base lies at the same side of unity, then log is positive. Similarly, log of x with base a less than 0. So when the argument and the base, argument is x and the base is a. So when the argument and the base lies on the opposite side of unity, then the log will be always negative. So to answer this question, before I will start solving this inequality, first we have to define the log. So for log to be defined, the argument of outside log must be positive. So this is the outside log, and argument of outside log is this whole expression. So for that I'm just doing log to be defined. First I'm calculating the values of x for which log has to be defined. So for that, for outside log, the argument is log of x square plus x upon x plus 4 with the base 6. So log of x square plus x upon x plus 4 must be greater than 0. This is, I'm not solving the inequality. I'm just finding out the values of x for which log to be defined. So log of x square plus x upon x plus 4 with base 6 must be greater than 0. Now as you can see, as I said here, if a log has to be positive always, then both x and a lies on the same side of the unity. So here the base is already greater than 1. So for this log to be greater than 0, this expression has to be, I mean, you can simply say the sign of inequality will not change. If base is greater than 1, the sign of inequality will not change. Okay. So we have x square plus x upon x plus 4 must be greater than 6 raised to power 0, that is 1. When you simplify this, let's see what we are getting. X square plus x minus 4 greater than 0 upon x plus 4. So x will be cancelled out. We further left with x minus 2, x plus 2 upon x plus 4 greater than 0. When you solve this, let's see what you will get. You can use Viveka method to answer this inequality. So plot this on the number line. When you plot, so minus 4, then we have minus 2. Let's do that. So minus 4, minus 2, then we have 2. I mean, I can't take this, so open circle. At the zeros, we have plus, minus, plus, minus. So we have to take the plus sign because greater than equal to 0 is there. So from here, minus 4 to minus 2, union 2 to infinity. So for the first thing that I have done is, I have just I have done only half of the calculation. I have only done the half of the calculation. Let's say this is the first set. Now, so I have defined the outside log is defined for x belongs to -4 to -2 union 2 to infinity. Now we have to define the inside log also. The argument of inside log must be greater than 0. So let's do that. So x square plus x upon x plus 4, x plus 4. So argument of the second log is x square plus x upon x plus 4. It has to be positive. Now I am defining the second log. It has to be greater than 0. Now when you solve this, what you will get, we'll have x into x plus 1 upon x plus 4 greater than 0. Draw a number line and plot the zeros of the factors. So -4, -1 and 0. Plus, minus, right? Now when you solve this, you will get x belongs to -4 to -1 union 0 to infinity. So this is the second set. Now when you take the intersection of these two sets, I'm just defining the log. After this, I will start solving the inequality. So -4 to -1 union 0 to infinity. When you take the intersection of these two, what you will get? So one intersection 2 will get -4 to -2 union 2 to infinity. Union 2 to infinity. So this is something, this is, you can say this is the values of, this is the value of x for which log to be defined. This is not my answer. Now I'm going to solve the inequality. The inequality we have is, let's do that. So log of 0.8, log of 6, x square plus x upon x plus 4 less than 0. This is the inequality, right? Now for outside log, this whole expression will be the argument. So if I want this expression to be less than 0, so from here I will get log of x square plus x upon x plus 4. So if I want left hand side to be less than 0, then the argument of outside log must be less than what? If I want to be negative, then argument of this outside log must be greater than 1. We have to change the sign of inequality because the base of the outside log is less than 1 and lies between 0 and 1. So it will be greater than 1. So for the solving, we have, now as you can see, the base is greater than 1. The base is greater than 1. So sign of inequality will not change. So we can write x square plus x upon x plus 4 must be greater than 6. Now bring all. So we have x square plus x minus 6x minus 24 upon x plus 4 must be greater than 0. Must be greater than 0. So finally we have x square minus of 5x minus 24. The solution is a bit lengthy. X plus 4 greater than 0. When you solve this, it comes out the factors. Let me calculate the factors. The factors are going to be, so the factors of this is going to be x minus 8 into x plus 3 upon x plus 4 greater than 0. Now when you solve this inequality by using wavy curve, x belongs to, it is going to be -4 minus 3 and 8. So it is going to be x belongs to -4 to -3 union 8 to infinity. So this is the value of x. This is the value of x after solving the inequality. But x has to be defined here. And this is the value of x for which log is defining. Okay, so log is defining for this set of values of x. And after solving the inequality, we are getting this value of x. Now again, we have to take the intersection of these two. Okay, because log also has to be defined. So when you take the intersection of this two, you will get -4 to -3 union 8 to infinity. So which option is correct? So in this question also, the option C is right. Nothing equality. So I think we are done with all the solutions. So thank you all. We'll meet again with the next solution.